We're looking at section 5, multiplying and dividing rational expressions. We're going to start with 5A, which is the multiplying. On number 2, this is a nice example to get started with. We have two fractions, no addition or subtraction going on in these fractions, so just straight up multiplication everywhere. If we look at our two fractions, whenever you are multiplying them, you multiply the tops and you multiply the bottoms. So whenever you're multiplying fractions, you multiply the tops, multiply the bottoms, and you can essentially then turn it into one giant fraction, which means that I can treat this as if it's all kind of meshed together. So I see that I have on the bottom a 12 and on the top a 6. So I could reduce this to 1 and to 2, divide those both by 6. I see that I have a 9 and an 18. I can reduce that to 1 and to 2, dividing them both by 9. Now the fact that I chose to go straight up and down instead of diagonal doesn't really matter. As long as you're working from top to bottom in these fractions, it's okay. It would not be okay for me to take those 2's and cancel them out because they're both in the denominator, so I have to leave those. One place this shows up here is with our n's. Down in the bottom I have an n to the 1 and on top I have an n to the 4. The top has more, it has 3 more n's, so get rid of these and I'm going to replace that with an n to the 3rd. And now it is fully reduced. So on the top my 1's just multiply together to make 1, so I have n cubed. And on the bottom I have a 2 times a 2 because everything's being multiplied, so I have a 4. So n cubed over 4 would be our final answer. Jumping down to number 7 here, this would be an example of one where you have some addition or subtraction going on in the problem. And whenever you do this, you always need to factor first before you start smashing everything together. In this part right here, the number pieces, the 6 and the 15, share a 3 in common, so I'm going to factor out a 3. And r cubed and r squared share an r squared in common, so I'm going to factor out an r squared. So my leftover, 6 divided by 3, is going to be 2. R cubed divided by r squared is going to leave you with just a single r. Plus, I have 15 divided by the 3 that I took out is 5. R squared divided by r squared cancels, so I'm going to be left with just 2r plus 5 here. So I'm going to cross out that original thing and replace it with my factored version. Up on top here, this is addition and subtraction as well, but r minus 4 is fully reduced. There's nothing you can factor out. Over here, 8r and 20, I know that they're both at even, so they're both divisible by 2 at least, and in fact if you keep dividing they are divisible by 4. So if I factor out a 4, 8 divided by 4 is 2, and then we have our r. 20 divided by 4 is 5, so I have 2r plus 5 right there, and that is as reduced as it gets, and I cross out my original. So now I go to my next phase of canceling things out, which is to turn this into one giant multiplication problem. Well, one thing I'm going to do just for clarity is when I do that, the original fractions I had, I'm going to throw some parentheses around those, just so I know that they're separate multiplied groups. So every group is being multiplied together on the top, every group on the bottom is being multiplied together. So I see that I have a 4 and a 4. Those can completely cancel each other. If it was a 2 and a 4, I could actually reduce it, but since they're the same, I cancel them out completely. 2r plus 5 on top and bottom, those fully reduce to 1 as well, so they disappear. And the only things I'm left with that I see here, I've got an r minus 4 and then I've got a 3 times r squared. And the since the r minus 4 is an entire group, it has to be matching an entire r minus 4 group. I cannot go cancel those r's. That is not something I can do. So my final answer is going to be that r minus 4 on top, 3r squared on the bottom.